Hello, welcome to the Marc Show, the cybersecurity show. In this video, I'm going to talk about how hackers create and write malware that is so good it bypasses any antivirus. So without further ado, let's get right into it. We're going dark. So what we're going to be talking about is the NIM, N-I-M, right, for creating the malware. So what are the advantages of using it, right? So there are several advantages to using the NIM programming language for creating malware. Number one, cross-platform compatibility, right? NIM's cross-platform features allow malware authors to target multiple operating systems and hardware architectures with a single code base. NIM code can be compiled and executed on diverse platforms, including Windows, Mac OS, Linux, and embedded systems, maximizing the reach and impact of malware campaigns. Number two, expressive syntax and meta programming. NIM's expressive syntax and high-level abstractions enable malware authors to write concise and readable code that is resistant to analysis and reverse engineering. NIM's support for meta programming and code generation allows for the creation of polymorphic and self-modifying malware payloads that adapt to changing environments and evade detection. Number three, performance and efficiency. NIM's efficient memory management, lightweight concurrency model, and native code generation enable malware to operate stealthily in the background without consuming excessive system resources or triggering alarms. NIM's minimal runtime overhead and fast execution speed make it suitable for malware payloads designed to minimize their footprint and maximize their impact. Next, we have safety and reliability. So NIM's strict type system and compile time checks help prevent common programming errors and memory-related vulnerabilities in malware code. NIM's emphasis on safety and reliability reduces the risk of crashes, instability, and unintended behavior in malware, increasing the longevity and effectiveness of malware campaigns. So next we have extensive libraries, and NIM provides access to powerful libraries like WinIM for interacting with the Windows API, Zippy for compressing and decompressing payloads, and NIM Crypto for performing cryptographic functions. These libraries enable malware authors to create sophisticated and stealthy malware. However, it's important to note that NIM binaries are often flagged by antivirus software due to the language's small user base in association with malware development. Malware authors can bypass these detections by understanding the signatures used by antivirus vendors and modifying their code accordingly. So what are the main libraries needed to create malware in NIM? So to create malware in NIM, several libraries are commonly used. These include, like I talked about, the WinIM, right? This library contains Windows API, struct, and constant definitions for NIM. It is essential for creating Windows-based malware. Number two, Zippy, Z-I-P-P-Y, and this library is used for compressing and decompressing payloads, which helps in evading detection by antivirus software. Number three, again, NIM Crypto, and this is NIM's cryptographic library used to perform various cryptographic functions. So it can be employed for encrypting and decrypting data, making it harder for security software to detect the malware. These libraries provide the necessary tools for malware authors to interact with the operating system and perform malicious actions. Please take a moment to hit the subscribe button and the like button. Please take a moment to hit the subscribe button and the like button. Now let's get into how they do it. Let's get into it. We have the sudo apt install NIM. So NIM is NIM, obviously, right? It's successfully installed just like any other programming language. NIM needs a compiler. Although it is compatible with many compilers, let's install the MINGW, right? The 64 compiler. As shown, Peter, put that on the screen. Put that on the screen, Peter, right? So the sudo apt get install ming w and then the w64. So as NIM is installed, Nimble will be available on the Kali Linux system. Nimble is the package manager of NIM language. So to create malware using NIM, we need to know, some more libraries, right? Important among them is the WinIM library, which contains Windows API, struct, and content definitions for Win. So this is important while creating Windows-based malware. Zippy is used for compressing and decompressing payloads. NIM Crypto is NIM's cryptographic library used to perform several cryptographic functions. So Nimble install WinIM Zippy NIM Crypto. Say that three times fast, right? Say that 3 times fast. Nimble install zippy nim crypto. So since all the necessary libraries are installed, it's time to create a payload using nim. A GitHub repository named offensive nim has many nim payloads. So we will download one nim payload from there and compile it. We download and the keylogger.nim payload from the Git repository and use the syntax on the screen. Peter, put that on the screen. Peter, keep putting that on the screen, right? The syntax right here to compile it. So the C option specifies compiling. The D option is used to specify compiler. The app option is used to specify the type of app to create. We can create 4 types of applications here. We have the console, GUI, lib, and static lib. We will create a console app here. So the CPU option is used to specify the target processor. So since our target is a Windows system, we are specifying the i386 option, which can run on both 64-bit and 32-bit systems. The nimcd app, right, and the equals console CPU i386. So this will create a Windows executable file with the same name as the .nim file. The payload is ready. Now let's test it, right? So you can copy it on your target system running a third-party antivirus, and you can see all the protection shields are active and the AV is updated. As the payload is successfully copied to the target system, the antivirus failed to detect it. So let's try executing our payload and see the response of the antivirus. Even as our payload is running, the antivirus failed to detect it. Now, this is good, but it ain't that good. It's good, but it ain't that good, you know what I mean? So let's try something meaningful. Let's try to get a reverse shell on the target system. So we change its L host and L port values and compile it in the same manner, that we talked about, right? So we start a ncat listener on the attacker system and execute the reverse shell payload on the target system. So as you can see, we got a successful reverse shell connection and the antivirus didn't even blink. So that's what I have for you today. Please take a moment to hit that subscribe button and the like button. Please take a moment to hit that subscribe button and the like button. Another thing that I realized that makes nim really effective is its Python-like syntax. Do you agree? Do you disagree? Please let me know in the comment section below. So please share the content. Please let me know your thoughts. Stay safe. See you in the next video.